Hi, welcome back to my channel. Today's video was inspired by a comment I got from a commenter who wanted to know if I had any advice on making programs be more robust, and to use the term future safe, which is I think is an excellent way of putting the notion of maintainability and extensibility into one big term, which is basically, will this program has a future, or when I get it out the door, is its time already ticking before it expires? So there are a lot of opinions around this, and certainly they're all over the place. And I can only offer my suggestions from my background and try to justify them as best I can. And I will follow on to this topic and do more things there, because I actually think it's something that's very interesting, and also something I was very passionate about, which was basically trying to do this. And one of the motivations I had for doing things with inside UML was that we really thought that having higher level diagrams and these types of documentation would really help make things last longer in terms of future proofing them. Now, that didn't play out. There's very reasons I won't get into it, but that doesn't necessarily mean I'm still not very interested in the topic. And so to demonstrate this, I'm going to actually basically do something which is basically not try to show up if, again, with the obvious kind of pre-baked educational example that will show you what's going on, but to show an example of how I screw it up and how easy it is to screw things up. And so let's start there. And what I've done here is that, again, we're doing the racket programming. For those of you that may have not seen any of my racket videos, I do a lot of stuff about racket on this channel. Is kind of why I ultimately created it, was just to kind of get back into programming, but do it in a way that I thought was fun. So I have popped this up, and I just loaded this as a file, and I've looked at it, and basically I've had some little bit of editing that I've done here already. But the thing about it is when I opened up, I was greeted with this. And one of the things that we'll point out is there's a whopping one little comment here that says eat white space. And that is basically one of the things about that basically recapitulates what this little teeny bit of thing does, right? But that's it. And now I'm looking at this and going, what does this actually do? And if I hadn't had some little examples of what I had done to try to experiment with this, I would have to be going through and literally reverse engineer this code to figure out what's going on here. Now, thankfully, I have a fairly good memory for these types of things. And that's actually what's made me fairly successful as a programmer, is that when I see this context, a lot of this just pops back up into my head, and I realize, oh, this is what I was all about. And so I kind of remembered, oh, this was a thing that I was working on when I wanted to show how to tokenize basically a calculation expression. Okay, and so basically I should have put at the very beginning, right? And then I could put in here, basically an example is tokenizing a string 1 plus 2 times minus 3. Okay. And then now I'll say, okay, now I've got myself, I had done that, I have put an anchor. Now the thing about it is what you'll see in a lot of things when people do documentation is there's a lot of documentation. What it seems to do is that, and this is why it's controversial why people do it, is that a lot of comments really just retell what the code is doing, but using English language. And that can be useful if it's high level enough. But what's more important is that I find that the documentation that's really useful is one that is providing clues into the narrative. And one of the things about this is that if you think about the idea of code tells a story in the way kind of like a video game tells a story, but you go through this and you're trying to define code that does a certain type of tasks, And as part of doing that, you're telling a lot of things about how to do that thing. And it's like there can be really complex narrative, there can be plot, there can be backgrounds, there can all be things in the scenes, all sorts of stuff that come from this kind of idea of telling a story. But we also have to do it in a very precise language, and just going over that precise language, the actual code, and higher level language doesn't really do anything, versus providing context for that precise language that helps glue those bits of code together in that larger narrative. So what we could do here is that you will see, and everybody will tell that this is a bad comment. This is a list of characters are digits, right? That is just restating this, right? But that doesn't necessarily mean that this doesn't deserve a comment. We can also say that's a why. Why did we do this? That's useful. And we're going to do the same here. And we're going, okay, tokenize expression string digits. Oh, this is a helper to try to tokenize out a different. And what it is that we define this helper function as tokenizing digits is a complex enough task to let's define this helper function as tokenized digits as is a complex enough task to be separated. Okay. And here the thing about it is that basically and I could just prefer the thing like this. This creates the token list. And this is kind of like, oh, okay, this is a little bit more what it does, but the why is now kind of basically, it's like, this is also the why. This is the whole point behind this entire code thing. So this is the function that gets the thing done. This is kind of the heart of the narrative. So this function creates the token list from a string. Okay. And now we can go off and look and say, well, what the heck did I throw in here? And the thing about it is that I now did this here. And one of the things I can do is I can start looking at this like, okay. And of course we are familiar with the fact that I can go off and just say, you know, I could just call this in this function here. I can go tokenize and look, it created that token list. How great is that? Okay. So that's the first thing. The first part of this is that when you're coding, you need to document. And the reason being is that it's very easy to forget. I'll even take this out because that doesn't make sense. That code is read way more than it is edited. And certainly we only write it the first time once. And that goes against the intuition that we'd have that we'd only open a code file as if we needed to fix a bug in it. Otherwise, we'd just be this basically this blob that no one would ever look into. The reality is in order to program, we must look and read the context way more often than we ever think. And if there's not anything that goes off and says, oh, this is how this connects to this larger idea that we have of why we're doing this software, then you will end up recreating that narrative in your head. And oftentimes it's the wrong thing. And not only that, but as a team, you might have 10 different versions of why this exists. 2 people think it doesn't even exist. 3 people think that it's wrong. 2 people won't understand it. And 3 people will just accept it. And if you have much more of these whys in there, okay, and then that really narrows that kind of down, and you can come to a much more robust understanding of basically what you need to do here and what this piece of code is for. So, of course, the thing about that is that Racket allows us to do this kind of thing. Other languages do not, and we would have to put those things inside unit tests. And of course, Racket does have a unit test library called RackUnit. Allows you to get, basically what we're going to do is that the standard Racket way of doing this is to create a separate file that imports that file or files as units to basically do this kind of thing in that. And because we did the unit thing, I'll go ahead and I have basically provided the 2 functions from this file that I want to export to other environments so that we can unit test them. And the first thing that RackUnit does is that at the very, very heart of it is it just does this. Check equals the following, which is basically, does this equal this? Now, the thing about it is interesting is that I want to go into a little bit about how I think unit testing works and what is maybe different than how other people do it. Red-green testing is actually fine if you can do that kind of thing. It's going to be a little bit repetitive, but there's some advantages to that. If you're trying to really figure out the kind of how you want an API to work, or basically interface for a class, sometimes just typing out the code as you would want to write it can be really helpful. And red-green unit testing can be good for that. But what I use unit testing for in a lot of cases is not necessarily to get 100% code coverage, but as basically a way of expressing the contract of a set of methods, or for a method or a set of methods in a class. And what I mean by a contract is to show by a set of unit tests what is not allowed and will return an exception or an error, and then to show basic examples of what is allowed and how I should expect that to work. And so it's one of those things where, for example, it's one of those things is that let's say I would do this. It's like, well, you know what? I think this is the Racket type of thing. So I expect if I try to, basically, if I go ahead and I basically tokenize and that string is empty, right? Then I expect to get false back, right? That it should just return false. And sometimes that's a pattern that a lot of Racket code uses, which is basically if you either return the thing, which is basically return the list or whatever you expect this to get back, otherwise return false if something didn't work out. So let's go ahead and we can actually run this. Okay. And lo and behold, it looks like it has a slightly different behavior. That tokenized expression string, if you give it an empty string, returns false. And not only that, but basically I had this other one, which is basically, oh, wait a minute, is that, oh, if you give it a valid string here, like this is 1, it should be a list. And it didn't do that. And now, the nice thing about Racket, which I really do like, and is one of the advantages that JavaScript has if you have the console, even though it's not nearly as nice as this, is to be able to go off and temporarily just add stuff. You know, you could just type this out here, put this in the REPL over here, and now you can say tokenized expression string 2, that returns an empty string. That's really interesting. That doesn't seem to be right at all. Okay. Well, what if okay, that's bad. See if it does anything different. Well, all of a sudden that seems to work, but not really. Because now it's 1 plus, oh, wait a minute, this is something going on here. So there's lots of bugs in this code. And I do remember that being the case, is that this I left kind of on the shelf for a while, and because there wasn't numerous things about it in here. And this kind of exposes just how bad this has kind of gotten, that there's just things that this does not do very well. And the interesting thing about this is that what's happened here is that I've thought, oh, well, I am doing really great because that just seems to be fine, right? That seems to be pretty good to me. Oh, wait a minute, it actually doesn't look very good at all. It's actually kind of just choked here after that right parenthesis. So, oh my goodness, what's going on? And so, yeah, that's where I go off and say, okay, you know what? I need to actually shore up my unit tests here to kind of show the basic contract of what was going on. That basically, it's one of those things where it's that if I parse the most basic of strings, that is an expression, I should get back something that is a list. And not only that, I could go off and then just basically say the following is that it should be, excuse me, that basically the car of that list should actually just also be just a string one. So this should also be true. Okay. Of course, all these have failed. So yeah, that's basically comes going to this thing. So unit tests should define the contract and provide a little bit more of the narrative in terms of like, oh, here's exemplars of how this should be used. That really provides its own set of kind of documentation. Then documentation that helps in the narrative in terms of like why this code exists and where it lives inside of the context of other code. Those are the two basic main operations that I think a lot of people miss in a rush to get code. Now, the thing about it is that these small operations are not necessarily a way you can get to some place better. Even though if you do that combined with a set of defined refactorings, in a lot of languages, that does help you to massively improve code bases by making sure that because you have a set of unit tests and you have these things that are defined refactorings that make sure that the code doesn't backslide, that semantically it is the same, just easier to then change into formats that work better for the problems you're trying to actually solve, then that's actually really good. But until you have an idea of the larger types of abstractions that you need, that's where it becomes very tricky. And that's where most projects fail because we really don't have a good idea of how to set the background to make code successful. And what I mean by set the background is that if we go back to the idea that basically a program is a story that we have to tell a computer so that it can do certain types of things. And we see it as a story because it does certain things and it works in the real world. We want it to do some real world things, but we need to use this very precise language because computers have to use these higher level languages to actually get anything done. And we have to be very specific in types of things in terms of what a computer can and can't do. It doesn't understand these higher level concepts. And not only that, but natural language, as a lot of people will tell you, is going to be obviously an extremely poor way for a computational environment to work. Having something that is a programming language that looks like a natural language, it doesn't work very well. Computers have a different set of abstractions and things they want to do that have nothing to do with how humans communicate in terms of language. So we use language as computer language very loosely in the fact that there's rules, semantics, and syntax. But beyond that, it really has nothing to do with human language if you really think about it. So the question is like, well, how do you get that kind of thing? And the thing about it is that ultimately, we've now kind of borrowed more and more of that in terms of when people talk about frameworks or libraries, it's one of those things where it's like, oh, well, that's what should give us the larger context of this set of best practices in. And we should borrow from that. The interesting thing about that is that I have found that is increasingly failing compared to older types of older programs, because you still have to come up with your own story. And if the background isn't quite right, or you don't have quite the set pieces or the quite little thing there, then the story kind of really suffers. And so you need more experience in how to tell that type of thing and how that works really well. And what I have recommended for that is that I do still think that there is a very good use for understanding things like requirement gathering and domain-driven design. I think there's some excellent concepts there in trying to capture abstractions that work well for telling that story that you're trying to tell when you're doing a product. The other thing now is that, and I'll go on into more of this later on in a separate type of thing, but one of the things I'll say is that what really is interesting about this to me is that in a lot of environments that we are more and more common with, this is just a harder and harder problem to solve. And to be perfectly blunt, the way I take a look at the modern web programming environment, where you have the front end especially, but the entire environment itself, the abstractions there and the way they built that up in terms of the frameworks and what the foundations that is on is fundamentally building castles on sand. That you have to do an amazing amount of work to get that to work, right? But the reason it's so hard is not necessarily something that can be solved by the developers that use the tools, but are inherent flaws in the environment itself. They're just not good abstractions for doing a lot of the things that people want to do with them. They're just not. And there are fundamental flaws in them that make things very difficult. And that is basically the web front end is a perfect example of that. And the reason is that it's obvious because there's so much churn there in terms of how not only that do you go from one framework to another, but how frameworks just completely change themselves over and over and over again and introduce new concepts. Oh, we don't do this. We do this now. We're not doing this or doing this. Not only that, but they also seem, the most popular ones, to be completely allergic to the patterns and ideas that have worked for all the underlying software that does GUI types of stuff for the last 20 years, which is basically object-oriented programming using careful use of inheritance in the model view controller paradigm. That works great. It's been proven over and over again for every type of things that you run on the desktop, including the browsers that these web things have to run in, right? The browsers themselves do not use the same type of abstractions that they are telling people to write applications in. And the reason they don't do that is because it won't work. It doesn't scale, it's not fast enough, and there's no need to, because they only have to do it once, and they only have to do it once right. And so they're going to do and take on that, basically what they've done with everything else, is that there's nobody in Chrome, the Chrome team or the Chromium people or Opera or anybody's saying, it's like, you know what? We're going to rewrite a browser in JavaScript, and we're going to try to bootstrap this whole environment. And the reason being is that it would just not be useful. And it goes against all this other types of stuff, is that when you're working with these underlying native things, either in mobile or on the desktop, that those environments are very much built on those MVC concepts, built on object-oriented languages that have inheritance and classes and all that ugly, overly verbose stuff that a lot of people don't like, but that's what they use. And there's a reason for it, because it's proven to work. And so I would just say to front-end developers, when you're doing this kind of thing like that, the best thing you can do is basically create a domain and a set of abstractions that have nothing to do with the GUI itself, and try to isolate things as much as you can. And that means using some object-oriented techniques that maybe a lot of people wouldn't like. Or basically accept the fact that this is going to be rewritten, and you should try to make it as thin as possible and punt that off to the back end. And the only reason that might help is that on the back end, you have more choices in terms of what languages you can use, and you might have some chances to use things that are a lot more fit for the problem that you want to solve. And I know if anybody gets this far into this, and I will back this up with another video, which will go into this directly and talk a little bit more about this, that basically it's like, well, you're ignoring the web has been very successful. I absolutely agree. It's been successful, but at the cost of quality. Web applications are fine at their best, but there's a lot of bad or things out there about them. And there's a lot of fundamental annoyances that we just accept every single day that if a desktop application did them, we would just completely lose our minds. We just accept that every single website is going to have its own slightly unique way of logging in or adding credit card information or doing little things like this. That drag and drop won't quite work, or maybe it will, or everybody has a slightly different way of uploading files. That's just the way it works. And if I was to go off and to do something like this in a desktop program, if this dialog doesn't pop up and it looks exactly like this in Windows, I am going to be mad. Because this is the standard dialog for finding a file in Windows. And if this is on Mac, I want to see what Mac is going to do. Linux is a little bit more complicated because it depends on the window manager, but there it is. And the fact is that the web is not going to get a lot better and more future-proof until they get a much better idea of an actual standard component model. Just too many things to fix, and I will get to that in another video. But going into this knowing that basically it's one of those things where you are going to be limited by those tools, especially in the web front end, by being able to do this. There's only so much you can do at shoring it up in terms of unit tests. But what can you do that really will help is you can still do the narrative thing. You can still go off and in that code say, why are we doing this? And be perfectly blunt, because there's going to be a lot of times, we're doing this because I don't know how to tell React to do something better and I can't find out why. Help. Right? That's an honest comment. This is the best I can do. This is a hack. I don't understand what's going on here. Don't touch this because React needs to do this. React needs to do it this way. Do not touch this CSS thing because of this. Put in the whys, and then, get the bigger picture, try to document that, and try to get that in some, get some requirements, get some of the, hey, welcome to this project. Here's why we're doing this thing from a high level. This is why you should care about coding this up. This is the problem we're trying to solve. Not going into every single requirement of it. That's going to be, basically communal knowledge, and you can find that when you need it. But basically, this is why we're here. This is why this team exists. And, make that fairly small, but, have it as GitHub, And if GitHub, instead of a standard README, there's also a README, but why is this here? Is a common markdown file. That'd be a great improvement where everybody could look at, why is this here? And that would be, okay, this is why we did this. And the README more is about, oh, well, here's all the things you need to know that really get this to work for you as best as possible. So anyway, this has gone on a little bit long, and I will do a follow-up again about why the current web frameworks have built up and accumulated so much technical debt by trying to just patch up fundamental problems and basically a fundamental lack of being able to improve the platform and move past the legacy code in a lot of ways is really holding things up and makes it so that those kind of codes are just fundamentally much more ephemeral, or they just won't last long. You'll just be constantly replacing them. Anyway, thanks for watching, and like and subscribe, and I hope to see you in the next video.